Okay, let's do an example using Kepler's third law, and this we're going to calculate Mars's orbit. Okay, so we watch Mars for a while. We figure out that the period of Mars around the Sun, so Mars around the Sun, is 1.88 years. Okay. Now, we want to find out what the radius of the orbit for Mars around the Sun is. Okay, and we're going to assume that it's exactly circular, so this would be like the average distance away from the Sun for Mars. Okay. Now, the other things we know is that the period for Earth to go around the Sun, or how long the Earth takes to go around the Sun, is 1 year. Okay, and we also know the distance the Earth is away from the Sun. On average, is 1.5 times 10 to the 11th meters. Okay, and we can look that up in front of the book, no problem. So to use Kepler's third law, we have this equation here. Okay, here we have the radius of Mars around the Sun, the radius of Earth around the Sun, the period of Mars around the Sun, and the period of Earth around the Sun. Okay, so r over r cubed equals t over t squared. Okay. Now, to solve this equation, we want to solve this for the radius of Mars around the Sun. To get rid of this cubed part, what we need to do is take the cube root of each side. Taking the cube root of each side is the same as taking this whole thing, or each side, to the power of 1/3. Okay? So when I take this to the power of 1/3, I get this raised to the 1, because we have 3 over 3. On the other side, we get this raised to the 2/3. Okay, so on this side we just get the simple ratio, r over r, and then we have the period over the period of Earth, and that whole thing is raised to the 2/3. Okay, so we got 1.88 years over 1 year, and we raise that to the 2/3. Now, in your calculator, if you know how to input fractions, you can put raised to the 2/3, and it'll do it. Otherwise, you could also square it and then take the cube root, and that would give you the same answer. Okay, so we find that the ratio of the radius of Mars around the Sun to the radius of Earth around the Sun is 1.52. Okay, now we know what the radius of the Earth around the Sun is. So we solve this for the radius of Mars around the Sun, and we plug in the radius of the Earth around the Sun, which is 1.5 times 10 to the 11th meters. And we multiply this out, 2.28 times 10 to the 11th meters. So basically we compared Mars's orbit around the Sun to Earth's orbit around the Sun, using Kepler's third law. Now, we could do this with any of the objects that orbit around the Sun. We could do it with comets. We could do it with asteroids, or the bigger planets, Jupiter. It doesn't matter. We can compare it to our period around the Sun and the radius of Earth around the Sun. Okay? Or if we knew some of the other planets' period and radius, we could use that to figure out one of the other planets' period and radius.